Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is flip-flops. The topic is from digital electronics. In this class, we will be seeing truth tables and excitation tables of SR flip-flop, JK, D and T flip-flop. Let us start with SR flip-flop. The first one, SR flip-flop, its circuit symbol is drawn here. This is a logic diagram of the SR flip-flop. S and R are the inputs and CP is the clock pulse. It is a positively H triggered flip-flop, so it is shown with this triangle. Q and Q bar are the output. The logic diagram of SR flip-flop. Writing its truth table. While writing the truth table of SR flip-flop, we need three inputs S, R and Qn. Qn is the present state and Qn plus 1 is the next state. So, we have written the truth table for three variables S, R and Qn. When there are three variables, we can write 8 possible combinations in the manner 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1 double 0, 1 0 1, 1 1 0, 1 1 1. So, we have written the truth table for these three variables. Now, how to write this output, the next state? So, we have to see here, when both S and R are 0 0, there is no change. No change means whatever is Qn, the same thing will be reflected at Qn plus 1. So, it written as 0 because it is 0 here. Again S and R are 0 0, no change state. No change means whatever is at Qn is reflected at Qn plus 1. So, it becomes 1. For next stage, when S is 0 and R is 1. So, what happens? This is known as reset state. So, whatever irrespective of this Qn, the output will be 0. When S is 0, R is 1, it becomes reset state. The Qn plus 1 will become 0. It does not depends on Qn. Now, S is 1, R is 0. In this state, Qn plus 1 is known as set 1. S is 1, R is 0, set state, output will be 1. It is again not depending on Qn. Okay. If S is 0, it is known as reset state. If S is 1, it is known as set state. When both S and R are 1 1, it is indeterminate stage. So, we symbolize it with X symbol. So, when S is 1, R is 1, it becomes indeterminate state. S is 1, R is 1, indeterminate stage. It does not depend on Qn. So, Qn plus 1 is depending only on Qn when both S and R are 0 0. Okay. So, this truth table can be written in this version also, where I have not written Qn column. We have taken two inputs, S and R are the inputs, 0 for two inputs, 4 combinations 0 0, 0 1, 1 0, 1 1. Okay. So, for 0 0, no change. No change is symbolically represented by Qn. Whatever is Qn, that value will appear here. 0 1, S is 0, so reset 0. S is 1, set state, output is 1. 1 1, indeterminate, X symbol. Okay. So, this truth table can be written either in this form or this form. The SR is very clear, 0 0 no change, 0 1 reset, 1 0 set, 1 1 indeterminate state. To write its excitation table, the inputs taken here are Qn and Qn plus 1. Okay. The inputs are for the two input variables, 4 combinations 0 0, 0 1, 1 0, 1 1. So, for 0 0, what will be the output? output are taken here as S and R. So you can see here Qn plus 1 is 0 at what condition? For 0 0, and it is also 0 for 0 1, for 0 1. So what is changing? S is all the time 0 and R is changing once it is 0, other time it is 1. So it becomes 0x. Okay. For 0 1, what is Qn plus 1? Set state. Qn plus 1 is 1 means set state, it means S is 1, R is 0. 1 0, Qn plus 1 is 0, 0 means reset state. So it will be 0 1. For 1 1, it is 1 1 at what condition? Qn plus 1 is 1 for 0 0 condition and for 1 0. So what is changing? S is changing and R is all the time 0. So we can write it as x0. So for 1 1, it becomes as x0. So this is how we write the excitation table for the SR flip-flop. Now coming to JK flip-flop, this is JK flip-flop having two inputs J and K. CP is a clock pulse. The truth table is written for three input variables J, K, Qn is the output. We have written for three variables the truth table J, K, Qn. Qn is a present output, Qn plus 1 is a next output. For three variables, 8 possible combinations, 2 to the power 3 is 8 combinations. So we have written as 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1. Okay, now see here, for 0 0 it is called as no change state. 0 0 no change. No change means whatever is at Qn that will appear at Qn plus 1. 0 0 no change. So what Qn is here, the same thing will be reflected here. So when J and K both are 0 0, we say this stage as no change state. Okay. For 0 1, when J is 0, K is 1, it is known as reset state. It is known as reset state. So it will not depend on Q1. When J is 0, K is 1, it becomes 0 0. When J is 1, K is 0, it becomes set state. Set state. So set means the Qn plus 1 will be set to 1. Both are 1 1. J is 1, K is 1. So what will happen? It will toggle. Qn plus 1 will toggle. Toggle means whatever is at Qn, it will become complement. It is 0 here, so it became 1. J and K are 1 1, so it will toggle. 1 will toggle to 0. So this is known as toggle state. Okay. So the truth table can be written in this form also. J and K 0 0 0 1 1 0 1 1. When both are 0 0, no change, Qn is appearing at Qn plus 1. 0 1, J is 0 means reset. Reset means output Qn plus 1 is 0. For 1 0, J is 1 means set state. Set means output will be 1. For 1 1, it is toggling. That is Qn plus 1 will be equal to Qn bar. That is known as toggle stage. No change, reset, set, toggle. Coming to the excitation table of JK flip-flop, it is written for two variables Qn, Qn plus 1. So for two input variables, 4 combinations 0 0, 0 1, 1 0, 1 1. So here we can see for 0 0 combination, when both are 0 0, what is the state of JK? It is also 0 0. When next Qn is 0, Qn plus 1 is 0. So at this stage, at these two stages if you see, J is 0 and K is changing. So you make K as X sign. So that is written here. For 0 0, it is 0x. For 0 1, it will be coming as 1x. If you see in this truth table, it will come as 1x, 1 0 x1 1 1 x0. Okay, this is the excitation table. See this one, when qn is 1 and qn plus 1 is also 1, and next time qn is 1, qn plus 1 is 1. So, under these two condition, what is happening? See, here j is 0 one time, other time it is 1. So, it can be written, j is written as x, and here it is all the time k is 0, k is also 0. So, it can be written as x0. So, for 1 1 it is written as x0. So, this excitation table you can easily refer it from the truth table and write, or else you can memorize it also. For 0 0 0 x 0 1 1 x 1 0 x 1 1 1 x 0. Coming to D flip flop, D flip flop is a single input flip flop. CP is the clock pulse. Okay, coming to its truth table, input variable is D, Qn. So, we have written that table for D and Qn. For two variables we can write 4 combinations, 0 0 0 1 1 0 1 1. So, here in D flip flop, whatever is the D input, the same thing will appear at Qn plus 1. Okay. So, it is 0 0 1 1. So, Qn plus 1 will become 0 0 1 1. So, what is Qn plus 1? Is same as the D input, that is written in this truth table in short form. D is the input, Qn plus 1 is the next output. So, if D is 0, what will be Qn plus 1? 0. If D is 1, Qn plus 1 will be 1. Whatever is the input, the same thing is going to reflect in the output. Coming to the excitation table input, generally we take it as Qn plus 1. For these two variables, 4 combinations, 0 0 0 1 1 0 1 1. So, whatever is at Qn plus 1, the same thing will appear at D. So, it is written as 0 1 0 and 1. Okay. So, D flip flop is very easy to remember, the truth table and the excitation table. Whatever is at D will appear at Qn plus 1, and coming to excitation table, whatever is at Qn plus 1 will be appearing at D. Coming to T flip flop, it is a single input flip flop having the clock pulse and 2 output Q and Q bar. So, the truth table is, first we have written for 2 variables T and Qn. For these 2 variables we need 4 combinations, 0 0 0 1 1 0 1 1. Okay. So, what is the output here? Qn plus 1 is a next state output, this is a present state output. So, T stands for toggle. So, whenever T value is 0, it will not toggle. Here T is 0, so it is not toggling. Whatever is at Qn, the same thing is appearing here. When T value is 0, no toggling. So, Qn value is reflected in Qn plus 1. When T value is 1, it becomes toggling. T value is 1, toggling. Toggling means Qn will become Qn bar. So, 0 will become 1, and T value is 1, Qn value is 1. So, it becomes, this 1 will become 0. Okay. This truth table can be written in this form. The input is T, Qn plus 1 is the output. So, when T value is 0, the output is same as Qn, no toggling. T is 0, no toggling. T is equal to 1, it causes toggling. Toggling means Qn bar. Coming to the excitation table, we write the excitation table for Qn and Qn plus 1. For these 2 variables, we have written the 4 combinations, 0 0 0 1 1 0 1 1. So, here we see from when the transition from 0 to 0, is there any change? No change. No change means t value is 0, no toggling. From 0 to 1, when you are going, there is a change. So, t value will become 1. 1 0 change, toggling, 1 0 change. So, t value is 1. For 1 1, there is no change. No change means t value is 0. This is the excitation table for the T flip-flop. Let us quickly summarize the excitation tables of all the flip-flops. Excitation table is for two variables Qn and Qn plus 1. For these two variables, we write 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. Coming to D flip-flop, it is very easy to write. Whatever is at Qn plus 1, the same thing is coming at D, that is 0, 1, 0, 1. Coming to T flip-flop, here you have to see the transition 0 to 0, no change. No change means 0. 0, 1, there is a change, so t value is 1. 1 to 0, change, so t value is 1. 1 to 1, no change. No change means t value is 0. Coming to SR, 0, 0, 0x, JK also is 0x. For 1, 1, it is x0, x0. Okay, coming to 0, 1, that is Qn plus 1 is the next state. So, it means it is 1 means definitely S value, it is a set state. Qn plus 1 is 1 means it is set. Set means definitely S will be 1, R will be 0. Here Qn plus 1 is 0. So, it will be set will be 0, R will be 1. So, for JK it will become 1x and x1. Okay. So, in this way you can quickly memorize and remember these excitation tables and truth tables for designing of counters. I hope you have understood the class. If you have any queries, you can post in the comment section.